Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. In this video, I will solve the problems of assignment 1 that I gave in the previous video, that is part 3 on the chapter of parallelograms. So this assignment, the problems are based on the properties of quadrilaterals and parallelograms. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author R.S. Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I strongly suggest that you also watch all the theoretical videos from part 1 to part 3 on the chapter of parallelograms. So let's get started in solving the problems of assignment 1 on quadrilaterals and parallelograms. Okay, so I have the problems on the left hand side. I hope the fonts are big enough that so that you can see them properly. The link to the PDF of this problem set will also be there in the description below. On the right hand side, I will solve the problems. After solving a problem, I will pause for a few seconds so that you can take a screenshot of the solution if you think it will help you. Okay, so let's start solving the problem. The first problem says that let n be the number of obtuse angles in a quadrilateral. Then we must have if n is the number of obtuse angles in a quadrilateral. Okay, so obtuse angle means an angle which is greater than 90 degree but less than 180 degree. So if theta is obtuse, we know that if theta is obtuse, this implies that theta will be greater than 90 degree and we will have this. Okay, so if theta is an angle of a quadrilateral, in quadrilateral we have 4 angles, and we know that sum of all the angles of a quadrilateral is always 360 degree. And it is asking that if n is the number of obtuse angles, that is an angle greater than 90 degree and less than 180 degree. And it is asking what can n be. The choice A is n equals to 2. N equals to 2 means that it is saying that there should be exactly 2 obtuse angles. Okay, n less than 3, n less than 4, and n equals to 3. Let's see if n can be 4. If n is equal to 4, if n is equal to 4, this will imply, if I consider theta 1, theta 2, or let's not take theta 1, theta 2, maybe this type of notation you're not familiar with. So let's say if ABCD is the quadrilateral, any quadrilateral, and if we assume we are trying to check every choices whether it is true or not. Okay, now we are seeing if n can be equal to 4 or not, even though n equals to 4 is not there in the choice. Let's see if n equals to 4 or not, can be 4 or not. So if n equals to 4, we will have that now all the angles will be greater than 90 degree. So angle A will be greater than 90 degree, angle B will be greater than 90 degree, angle C will be greater than 90 degree, angle D will be greater than 90 degree. If I consider these to be 3 results, if I adding 1, 2, 3 and 4, I get angle A. If you have, I will get angle A plus angle B plus angle C plus angle D is equal to, not equal to, it will be greater than 90 degree plus 90 degree plus 90 degree plus 90 degree. The idea is that if you have this kind of mathematical relation, this is called an inequality. That is, x less than y is an inequality. X equals to y will be an equality or equation. X less than y is an inequality. If we have this, and let's say we have p less than, let's say, q, using these two fact, we can say, we can add up all the LHS, that is x plus p will be less than y plus q. Instead of less than sign, it can be greater than sign also. It will be similar, the result will be similar. So I have applied this concept in these four results or equation. So this implies that angle A plus angle B plus angle C plus angle D is coming out to be, on the right hand side there is 490 degrees, that is 360 degree. This is not possible. This is not possible because we know that sum of all the angles of a quadrilateral is always 360 degrees. So n equals to 4 is not possible. This is not possible. So definitely n has to be less than 4. Let's see if n can be 3 or not. If n is 3, if n equals to 3, let's say so this means that 3 angles of the quadrilateral are obtuse. So let's say let's say angle A is greater than 90 degree, let's say angle B is greater than 90 degree, and angle C is greater than 90 degree. Let's say these are the angles which are obtuse. Now, so this will imply that angle A plus angle B plus angle C will be greater than 270 degree. Applying the same concept, if I add up all these results, add up all these three results, I will get angle A plus angle B plus angle C is greater than 3 into 90 degree, that is 270 degree. Okay. Now also angle A plus angle B plus angle C plus angle D is equal to 360 degree. So this implies angle D will be equal to 360 degree minus the sum of angle A plus B plus C. Now we know that since each of the angles angle A, angle B and angle C are greater than obtuse and greater than 90 degree, that is, they are obtuse, their sum is greater than 270 degree. So this will imply that angle D will be greater than 360 degree minus 270 degree, because angle D is 360 degree minus the sum of A plus B plus C, and the minimum value and A plus the sum of A plus B plus C is greater than 270. So this will mean that D will be greater than 360 minus 270. It will be greater than or less than. It will be less than, angle D will be less than 360 degree minus 270 degree, that is angle D will be less than 90 degree, which is possible. So n equals to 3, that is there can be 3 obtuse angles in a quadrilateral. An example is a kite. If you consider a kite, you can always have a kite where 3 angles are obtuse angles. So I am trying to roughly draw a kite. So definitely this is obtuse. This is greater than 90 degree. This angle is also greater than 90 degree, and also this angle, it may look like 90 degree, but you can make this angle greater than 90 degree. So we have three obtuse angles and it is a quadrilateral, and this angle is definitely has to be less than 90 degree. So there can be three obtuse angles in a quadrilateral, but the choice D says n equals to 3. It means that there has to be, n equals to 3 means there has to be three obtuse angles. No, it is not the case. I can have it is absolutely not a necessity that there has to be three obtuse angles. For example, if I take a square, this is a quadrilateral. This is a quadrilateral where all the angles are 90 degree. Where all the angles are 90 degree. These angles are not obtuse. 90 degree is not obtuse. 90 degree is acute. Not acute, at least it is not obtuse. So we can see that it is not necessary that three angles has to be obtuse. Okay. So definitely choice D is incorrect. Choice C is correct because we can choice C is correct because we can see that there cannot be four obtuse angles, and there can be n. So n, we have already seen that n cannot be 4 and n can be 3. So we know that at least n should be less than 4. This is true. This is true. So far we have seen that n cannot be 4 and n can be 3. So this means that n should be less than 4. Okay, and n equals to 3, it is not necessarily true. So now n less than 3, no, choice B is also incorrect because n less than 3 means n can be 1 or 2, or n can be 1 or 2. But we have already seen that n can be 3. There can be three obtuse angles. So B is false, D is false, and definitely A is also false. If n can be 3, then definitely it means that n equals to 2 should not be true. So the only choice we can go with is n less than 4. So the correct choice is n less than 4. So the correct choice is C. So in fact, you must know that in a quadrilateral there can be maximum 3 obtuse angles. There can be maximum 3 obtuse angles. Okay. Let's see problem number 2. Okay, problem number 2 says there is a figure in the parallelogram PQRS. So PQRS is a parallelogram. Angle R is obtuse angle. It is given that angle R is obtuse means angle R is greater than 90 degree and angle R is less than 180 degree. That is the meaning of an obtuse angle. Okay. What else is given? It is given Rn, Rn. Okay, so we have Rn. This is Rn is perpendicular to PS, perpendicular to the side PS. Okay, and also Rm. This is M is perpendicular to the side PQ. Okay, angle MRN is given to be 30 degree. Find angle R. We have to find angle R. Okay. So we have to find angle R. This angle is given. Now if we can somehow find these two angles, let's call it angle X degree and let's call this angle Y degree, then we can say that angle R will be equal to 30 degree plus X degree plus Y degree. Now, can we find the angles X and Y? Okay. This is 90 degree. Okay, this is 90 degree. What can we have from this is 90 degree? Okay, now, okay, so in triangle, let's try to use all the facts that has been given. So in triangle RNS, in triangle RNS, we have angle. We must have, since the sum of the angle, using this angle sum property of a triangle, that is sum of the angles of a triangle is 180 degree. We must have angle NSR plus the x degree should be equal to 180 degree minus 90 degree, because one angle of the triangle RNS, that is the angle RNS, is we have, it is given that angle RNS is 90 degree. So angle NSR plus x degree should be equal to 180 degree minus 90 degree, that is equal to 90 degree. Okay, now what is angle NSR? Angle NSR, this angle is nothing but the angle S of the parallelogram. So we have angle S plus x degree is equal to 90 degree. Okay, similarly, if we consider the triangle in triangle QMR, we have angle RMQ. Angle RMQ is 90 degree. Using the angle sum property, we must have RMQ plus angle MQR plus the y degree is equal to, should be 180 degree. This implies angle RMQ is given to be 90 degree because RM is perpendicular to the side PQ, and angle MQR is nothing but the angle Q of the parallelogram. So we have this. Okay, so this implies we have angle Q plus y degree is equal to 180 degree minus 90 degree, which is equal to 90 degree. Okay. So we have S and Q. So we have this result. This is, let's say, result 1, and we have this result, angle Q plus y degree is equal to 90 degree. Let's say this be result 2. We know, so if we add up 1 and 2, we will get x plus y. So angle R is equal to 30 degree plus x plus y. So x degree plus y degree, we just need the value of, we need not find the actual values of x degree, x and y. Even if we can find the value of x degree plus y degree, we will know the angle R. So if we add up equation 1 and 2, on the left hand side we will get x degree plus y degree, but we will also get angle S plus angle Q. What can we say about angle S plus angle Q? Okay, 1 minute. This is also 90 degree. This is also 90 degree. This is also 90 degree. Okay. Okay. So one interesting fact, in quadrilateral, in PMRN, in quadrilateral, lateral, we know that sum of the interior angles of a quadrilateral is 360 degree. So we must have angle P, we also must have angle 30 degree and plus 90 degree plus 90 degree is equal to 360 degree. So this implies we will get the value of angle P is equal to 360 degree minus minus 360 degree minus on the left hand side we have 90 plus 90, that is 180, 180 plus 30 is 210, 210 degree. This is equal to 150 degree. So angle P is 150 degree. This is 150 degree. This is 150 degree. Oh, that was quite simple. It was not necessary. Now we can easily say if angle P is equal to 150 degree, then definitely angle R will be equal to angle P, as they are opposite pair of angles. So angle R is equal to 150 degree. It was not at all necessary to find X and Y. Okay, so we just had to utilize the properties of the quadrilateral PMRN, and where we know that we already in the quadrilateral PMRN we already know three angles, that is two are right angles and one is 30 degree, and we could easily get from there the angle P, and from the properties of parallelogram angle P will be equal to angle R, and hence angle R is equal to 150 degree. So the answer is choice B. B is the correct choice. So this part was not necessary. This part was not at all necessary. I am crossing it. Okay. Let's do problem number 3. In this figure, what is the sum of the angles A, B, C, D, E, F, G, H? So we can see that these there are four triangles. There are four triangles. I hope the figure is quite understandable. It is a pretty clear figure. So you can say that we are having, let's say, in the center we are having the quadrilateral PQ, let's say R and S. Now, please note that since this is all about quadrilaterals and triangles, obviously it is obvious that we have to use the angle sum property and some basic concepts of lines and angles and parallel lines. So this angle is equal to this angle. They are vertically opposite angles. Similarly, this angle is equal to this angle. They are vertically opposite angles, and this angle is equal to this angle, and finally this angle is equal to this angle. I am using different strokes. That is the convention to indicate equality of different angles. So we have this. Okay. Now let's give the triangles some name. Let's say A, B, this is C, D, E, F, G, H. We will use the angle sum property of triangles and also the quadrilateral. So in triangle ABP, we have angle A plus angle B plus the other angle, that is angle A, and that is angle APB is equal to 180 degree. So this implies angle A is given to be A, angle B is given to be B, and we have angle APB, angle APB is vertically opposite angle to the angle P of the quadrilateral. So we have this. Okay. Similarly, in triangle, we have to do this for all the triangles. In triangle QCD, we will have angle C plus angle D of the triangle QCD, and the vertically opposite angle will be equal to angle Q of the quadrilateral. This is equal to 180 degree. Now angle C in the triangle is given to be C, and angle D is given to be D plus Q, is equal to 180 degree. So let this result be 1, let this result be 2. Again, in triangle FRE, in triangle FRE, we will get similarly E, I'm directly writing the values angle E plus angle F plus angle R will be equal to 180 degree. Let this be result 3. And finally, in triangle HSG, we will get G plus H plus the other angle, which is vertically opposite angle to the angle S of the quadrilateral. We will have this. So we have got 4 results or 4 equation of angles. If we add up all these 4 equations, adding 1, 2, 3 and 4, we get, when we add equation, we just equate the sum of all the LHS and to the sum of all the RHS. So we have A plus B plus angle P. I'm adding all the LHS, this plus C plus D plus angle Q plus E plus F plus angle R and G plus H plus angle S is equal to, on the right hand side we have all 180 degrees. So if we add them up, we have 4 equation. It will be 180 degree into 4 which is 720 degree. Okay. Now if we simplify, rearrange the LHS, we will get A plus B plus C plus D plus E plus F plus G plus H, and if we keep the angles of the quadrilateral, group all the angles of the quadrilateral, we have angle P plus angle Q plus angle R plus angle S is equal to 720 degree. Now angle P plus Q plus R plus S is 360 degree, because we know that in a quadrilateral all the sum of all the interior angles of a quadrilateral is 360 degree. So we will have A plus B plus C plus D plus E plus F plus G plus H should be equal to 720 degree minus, if we the sum of P, Q, R, S angles is 360 degree. If I take that to the right hand side, it becomes this is equal to 360 degree. So the sum of all the angles from small a to small h, A, B, C, D, E, F, G, H is equal to 360 degree. So the correct choice is B. B is the correct choice. Okay. Let's do question number 4. Question number 4, in the figure, it is given that in the quadrilateral ABCD, so ABCD is a quadrilateral, sides AB and CD are produced to P and Q respectively, then the sum of the angles x degree and y degree is equal to. So ABCD is a quadrilateral. Okay. AB has been produced to P, so we can say that angle A of the quadrilateral ABCD, angle A plus x degree should be equal to 180 degree, as the angle A and x degree are a linear pair of angles. Similarly, we will have angle C plus y degree is equal to 180 degree. Okay. Oh, sorry. What are the choices? So x degree plus y degree is equal to, it is all the choices are given in terms of angle ABCD. Okay. I thought I was thinking to find the values of x and y. We have, so if I, so this is fine, but uh, from this if we add up, um, uh, okay, let's see what do we get if I now add up. We have these two question. So if I add up, adding 1 and 2, what do we get? We get angle A plus x degree plus angle C plus y degree is equal to 180 degree plus 180 degree, which is equal to 360 degree. Okay, so this implies, let's group angle A plus angle C, and then we have x degree plus y degree is equal to 360 degree. We have to find x plus y degree in terms of the angles. A plus C. Okay. So now we know that in the quadrilateral, the sum of all the interior angles, that is angle A plus angle B plus angle C plus angle D, will be equal to 360 degree. So angle A plus angle C will be equal to 360 degree minus angle D plus angle B, and we have x degree plus y degree is equal to 360 degree. Since we know that angle A plus angle B plus angle C plus angle D, that is the sum of the interior angles of a quadrilateral, is equal to 360 degree. So this implies that 360 degree, if we simplify, open up the brackets on the left hand side, we get 360 degree minus of angle D plus angle B plus x degree plus y degree is equal to 360 degree. Now we have an equation, we can cancel out 360 degree from both the sides, and this implies, and if so this implies that minus of angle D plus angle B plus x degree plus y degree equals to 0, and if I transpose the sum of angle D plus angle D to the right hand side, I get x degree plus y degree is equal to angle D plus angle B. So x degree plus y degree should be equal to angle D plus angle B. So the correct choice should be B. B should be the correct choice. Okay, let's do problem number 5. In the parallelogram ABCD, where is it? Oh, okay. So ABCD is a parallelogram. In the parallelogram ABCD, AM is angle bisector of A. So AM is angle bisector of A. So this means that this angle should be equal to this angle. Okay. And bisects BC at M. The angle bisector AM also bisects the side BC. So this means BM should be equal to MC. So we have BM is equal to MC, and we have angle BAM is equal to angle MAN. Okay. Okay. So BN is the angle bisector of B. BN is the angle bisector of B. So these two angles are equal. These two angles are equal. BN is the angle bisector of B that intersects AD at N. Okay, fine. Then the ratio of AN is to DN. Okay, so the ratio of AN is to DN. Hmm. Mm, mm. So definitely I can see that we have to somehow use the concept of congruence of triangles. Uh, intuitively it feels that BN will also bisect the side AD, that is AN should be equal to ND, but we have to prove that. How can we prove? Uh, Now we know that in the parallelogram ABCD, since this is a parallelogram, the opposite sides are parallel and equal. So we must have AD is equal to BC. AD is equal to BC. Okay. We need to check if AN is equal to BM or not. This is equal to this angle bisector. Let's join M and N and see what happens. What do we get? Now we need to utilize the fact that we used to utilize the fact of the angle bisectors. This angle, this angle, this. Mm. 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 This AN is parallel to BM. AN is parallel to BM. So this angle should be equal to this angle. This angle should be equal to angle A and B should be equal to angle NBM. This is equal to this. Okay, so we're having this is equal to this. This parallel lines angle should be equal to this angle. Okay, so it's a bit of not complicated, I would say. It's you need to observe the triangles and the angles very carefully and understand. So we need to in a parallelogram always in this kind of problem always you use the properties of the parallelogram, that is the opposite pair of sides are equal, they are parallel, so we will have alternate interior angles, equal alternate interior angles, and the sum of adjacent angles are 180 degree. All these concepts should be at your fingertips, and you should be smart enough to use any of these properties to solve a problem. So I think what I will do is, I know that since ABCD is a parallelogram, I can say that AN is parallel to BM. AN is parallel to BM. Now, so this will imply, and I can say, um, I can say AM is a transversal. Transversal. So AN is parallel to BM, and AM is a transversal that intersects, that cuts the two parallel lines AN and BM. So this will imply the alternate interior angles should be equal. So this means I can say that angle NAM should be equal to angle AMB. That is angle so the angle NAM should be equal to angle AMB. Also, we know from the fact that AM is an angle bisector. We know that angle BAM is equal to angle MAN. MAN. Uh, BAM BAM is equal to angle MA. BAM is equal to angle MAN, and the naming is confusing me. Uh, so let's instead of give a angle NAM, angle NAM is this angle is equal to angle AMB. AMB, okay, and angle. So this is basically angle NAM. NAM. Angle BAM is equal to angle NAM based on the fact that AM is the angle bisector. So this will imply from these two we can say that angle AMB is equal to angle BAM. Angle AMB is equal to angle BAM. So this will imply in triangle ABM is a isosceles triangle because two angles are equal. This uh, this angle is equal to this angle. So we have in triangle ABM we must have AB is equal to BM. That is, in a triangle, if we have in an isosceles triangle, uh, the pair of sides opposite to the equal angles are equal. So we have AB is equal to BM. So AB is equal to BM. Fine. AB is equal to BM. Okay. What can we say? Uh, again, uh, again, AN is parallel to BM, and if we consider BN as the BN is a transversal, this will imply AN is parallel to BM, and if BN is a transversal, so we can say that this angle should be equal to the angle BMN. So we must have angle ANB should be equal to B should be equal to MBN should be equal to No, aim is the okay. So we have and BN is a transversal. So we will have angle ANB is equal to angle uh, NBM. NBM, and also we have, so this will imply that angle ABN is equal to angle ANB. So this angle is equal to this angle, and we already know that BN is the angle bisector of angle B. So we must have angle ABN is equal to angle BMN. So this implies, so we have angle ABN is equal to angle ANB. So this implies in triangle ABN, in triangle ABN, it is a isosceles triangle, and we will have AB is equal to AN. AB is equal to AN, since from the fact that the pair of the pair of opposite sides to the pair of opposite sides to the equal angles in an isosceles triangle are equal. So in triangle ABN, we are having AB is equal to AN, and we already have AB is equal to BM. So these two facts now will imply uh, these two facts will imply AB is equal to BM and AB equals to AN. This definitely can say, this will say that BM is equal to AN. BM is equal to AN. Now if BM is equal to AN, BM is equal to AN. Okay. Now BM is half of BC. BM is half of BC because BC has been bisected by AM at the point M. So we can say that so AN, we see AN is equal to, we have AN is equal to BM. Now what is BM? BM. Now what is BM? BM is equal to half of BC. Half of BC. Now this will BC is again equal to AD. BC is equal to AD because BC and AD are opposite pair of sides and they are equal in a parallelogram. We can say half of PD. So if AN is half of BD, this will imply that ND has to be BD minus AN, which is equal to BD minus half of BD, which is equal to half of BD. So we have ND is equal to half of BD and AN is also equal to half of BD. So this implies AN is equal to ND. So this implies the ratio, then the ratio AN is to DN should be equal to 1 is to 1. 1 is to 1. So the correct choice is D. D is the correct choice. Okay, let's do the last problem, that is question number 6. It says, okay, so we have in this figure ABCD and PQRS are parallelograms. Okay, so we have ABCD is a parallelogram and PQRS is a parallelogram. Angle POD, so this point is O. Angle POD is given to be x degree. Angle B is given to be 70 degree, and angle R, the ratio of angle R to angle PDC, the ratio of angle R to angle PDC is given to be 1 is to 2. Then we have to find x. Okay. 70 degrees given. If so ABCD is a parallelogram. If in a parallelogram one angle is given, then you can find all of the angles. In parallelogram ABCD, we will have angle D is equal to, in a parallelogram, the opposite pair of angles are equal. So angle D should be equal to angle B, which is given to be angle 70 degree. So D is 70 degree. Okay. D is 70 degree. And the angle D is nothing but PDC, angle PDC. So this is basically angle PDC. R. R is to PDC is 1 is to 2. Then find X. D is 70 degree. Okay. So D is 70 degree means angle PDC is 70 degree. Now it is given that angle R by angle PDC is equal to 1 by 2. So this implies that angle R is equal to angle PDC by 2, which is equal to angle PDC is we have found to be 70 degree by 2. So this is 35 degree. So angle R is 35 degree. So this is 35 degree. Okay. So if this is 35 degree, then this implies that in parallelogram, PQRS, angle P and angle R are pair of opposite angles. So we must have angle P should be equal to angle R, which we have found to be 35 degree. So angle P is 35 degree. Now in triangle POD, we must have angle OPD plus angle PDO plus the x degree should be equal to 180 degree. That is, sum of three angles in a triangle is 180 degree. This is angle sum property of a triangle. This implies, what is angle OPD? Angle OPD is nothing but the angle P of the parallelogram PQRS. And what is angle PDO? Angle PDO is nothing but the angle D of the parallelogram ABCD. And we have this is equal to 180 degree. Okay. Now angle P and D we already know. Angle P is equal to 35 degree and angle D is equal to 70 degree. We have 35 degree plus 70 degree plus x degree is equal to 180 degree. So from here we can easily find x degree to be equal to 180 degree minus 35 degree minus 70 degree, which is equal to 180 degree minus 105 degree, which is equal to 75 degree. 75 degree. So x is 75 degree and hence the correct choice is D. So this brings to an end in solving the 6 problems of assignment 1. These are good problems. For solving these kind of problems, you must be very well aware of the fundamental properties of quadrilateral, that is the properties of the sum of the interior angles, some of their exterior angles, and the parallelogram, properties of parallelogram, that opposite sides are parallel and equal, opposite angles are pair of opposite angles are equal, the sum of adjacent angles is 180 degree. All these things you must be well aware of to solve this kind of problem, and also the basic concepts of lines and angles, some properties of triangle. All these things will come into play. So I hope this video was beneficial. This will give you a good practice of solving problems on properties of quadrilaterals and parallelograms, and will also evaluate your understanding of these concepts. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. In this playlist only, the next videos will be on the special type of quadrilaterals or parallelograms, that is square, rectangle, kite, rhombus, trapezium, and isosceles trapezium. So I will complete these videos. I will discuss each of these figures or geometry in separate videos, and after they are complete, I will prepare and solve few more assignment problems, and then I will start 5 good problems in the other playlist, that is Maths 8 Hot, which will be based on the entire concepts of polygons, quadrilaterals, and parallelograms. So please stay tuned for all these videos coming soon. I will end the video here. Thanks for watching, and until the next video, take care and bye.